This is the first question of this test. The degree of polynomial having zeros -3 and 4 only. The word only is important. So the polynomial, let's call it p of x, has only 2 zeros. So such polynomial can only be a quadratic polynomial, because quadratic polynomial is of degree 2 polynomial is called quadratic polynomial, and it has 2 zeros. The answer to the first question is A. Second question, the quadratic polynomial, the sum of whose zeros is -5 and their product is 6. So we have been given, let's call alpha and beta are zeros of the polynomial, and sum of the zeros is given as -5 and product of the zeros is given as 6. And we know the general form of a quadratic polynomial. If alpha and beta are zeros of f of x, then f of x will be equal to x square minus alpha plus beta x plus alpha beta. By substituting the values of alpha plus beta and alpha beta, we are getting x square minus of -5x plus 6, which can be written as x square plus 5x plus 6. So option B is the correct answer. Sorry, option A is the correct answer. Answer option A. Third question, the quadratic polynomial p of x with -24 and 4 as a product and one of the zeros respectively is. So for the quadratic polynomial p of x, let alpha and beta be zeros. So we have been given that the product of the zeros, that is alpha beta, is equal to -24, and one of the zero is 4. Let's say alpha is equal to 4. Now we can substitute the value of alpha here so that we can get the value of beta. So 4 into beta is equal to -24. That means beta should be equal to -24 by 4, which is, that gives beta is equal to -6. So we have alpha and we have beta. We can find the value of alpha plus beta. Alpha plus beta is equal to 4 plus -6, that is 4 minus 6. Alpha plus beta is -2. The last question, we saw a general form. Using the same general form, we can write p of x is equal to x square minus -2x, and the product of the zeros was given as -24, which can also be written as x square plus 2x minus 24. So for this question, option B is the correct answer. The answer is option B. Zeros of the quadratic polynomial x square plus 99x plus 127. We need to find the nature of the zeros of this polynomial, whether they are both positive or negative. So based on the relation between zeros and the coefficients, we can say that the product of the zeros is 127 by 1 or 127, which is positive. So we got the product of the zeros as positive number, and sum of the zeros is minus b by a, and in this case it is 99. Sum of the zeros is 99, but it should be equal to minus b by a. So sum of the zeros is a negative number. Only then we can get a positive number here. So alpha plus beta, or sum of zeros is negative. The only way that two numbers sum is negative and their product is positive is both should be negative. Only when two numbers are negative numbers, when we add them also we will get negative, and when we multiply them we will get a positive number. So the correct answer is option B, both negative. If 2 and alpha are zeros of 2x square minus 6x plus 2, then the value of alpha is. So we have been given a polynomial and one of the zero is given. We need to find the other zeros. Based on the relation between zeros and coefficients, the sum of the zeros alpha plus beta is equal to minus b by a, or minus coefficient of x by coefficient of x square. In this case it will be minus of minus 6 by 2. The sum of the zeros is equal to 6 and 2 will get cancelled and we will get plus 3. They have given the value of beta as 2. We need to find alpha. So alpha plus 2 is equal to 3. Alpha equals 3 minus 2. So alpha is 1. So option C is the correct answer. Number of polynomials having zeros 1 and minus 2 is. So there could be a lot of polynomials having the same zeros. That is why when we build a polynomial from two zeros, we will usually do alpha plus beta is equal to, and we will find the sum of the zeros, and in this case it is 1 plus minus 2, which is minus 1, and product of the zeros should be equal to 1 into minus 2, which is minus 2, and from the general form, that is x square minus alpha plus beta into x plus alpha beta. Usually the general form is written along with a constant. So k into x square minus alpha plus beta x is minus 1. So this will become plus x and this will become minus 2, and k could be any number. So any number if we put in the place of k, still the zeros of the polynomial will be 1 and minus 2. So there could be infinite number of polynomials. So from the given options, more than 3 is the correct answer. Answer is D, more than 3. If one root of the polynomial 5y square plus 13y plus m is reciprocal of other, then the value of m is. So the roots of this polynomial are alpha and 1 by alpha. The roots are reciprocal of each other. Now we need to find the value of m. So we know that the product of the zeros, should be equal to constant by coefficient of x square, constant by a. So in this case, product of the zeros will become alpha into 1 by alpha will be 1. Alpha will get cancelled, and the constant value is m. Coefficient of x square is 5. So we are getting 1 is equal to m by 5 and m is equal to 5. Option D is the correct answer. Both options C and D are correct answer. If the zeros of the quadratic polynomial x square plus a plus 1 into x plus b are 2 and minus 3, then we need to find the values of a and b. So let the zeros be alpha is equal to 2 and beta is equal to minus 3. Now the sum of the zeros alpha plus beta is equal to the coefficient of x divided by coefficient of x square. In this case, coefficient of x is a plus 1, coefficient of x square is 1. So we can substitute the values of alpha and beta. We will get 2 minus 3 is equal to a plus 1. That means 2 minus 3 will be minus 1 is equal to a plus 1. A is equal to minus 2. The same way we can find the value of b by using the product relationship. Product of the zeros alpha beta is equal to constant term divided by coefficient of x square. So in this case the product will be 2 into minus 3 equals b. That means b is equal to minus 6. Sorry, this part is wrong. The product of the zeros should be equal to minus 6 and alpha plus beta should be equal to minus coefficient of x by coefficient of x square, which means minus a plus 1 divided by 1 is equal to alpha value is 2 and beta value is minus 3. That gives us minus 1 is equal to minus a plus 1. Both the negative terms will get cancelled and we will get 1 equals a plus 1. That means a is equal to 0. So a is 0 and b is minus 6. So the correct answer is D. If 1 0 of the quadratic polynomial f of x is equal to 4x square minus 8kx minus 9 is negative of the other, find the value of k. So it's given the zeros as alpha and minus alpha. 1 0 is negative of the other. So we need to find the value of k. The sum of zeros should be equal to minus coefficient of x by coefficient of x square. In this case, sum of the zeros will be 0. Alpha plus minus alpha is equal to minus of coefficient of x square is minus 8k and coefficient of x square is 4. So alpha minus alpha will become 0 and this will be 8k by 4. So k is equal to 0 into 4 by 8. K is equal to 0. So the correct option is D. If one of the zeros of quadratic polynomial a minus 1x square plus ax plus 1 is minus 3, then find the value of a. So the given polynomial p of x equals a minus 1 into x square plus ax plus 1. And it is given that one of the zeros is minus 3. That means we know p of minus 3 is equal to 0. Now we can substitute the value of 3 here and equate it with 0. That will give us a minus 1 minus 3 square plus a into minus 3 plus 1 equals 0, which means a minus 1 into 9 minus 3a plus 1 equals 0. 9a minus 9 minus 3a plus 1 equals 0. 9a minus 3a will become 6a. Minus 9 plus 1 will become minus 8. That means a is equal to 8 by 6. When we cancel it with 2, we will get a is equal to 4 by 3. And option A is the correct answer. Find the value of p for which 1 0 of polynomial 3x square minus 4x plus p is reciprocal of the other. So the zeros of this polynomial are alpha and 1 by alpha. And we need to find the value of p. Now the product of the zeros will be equal to constant term divided by coefficient of x square. In this case, product of the zeros will be alpha into 1 by alpha, which will become 1, and the constant term is p, and the coefficient of x square is 3. So that gives us 1 is equal to p by 3, which means p is equal to 3. Answer to this question is 3. Find the zeros of the given quadratic polynomial 6x square minus 13x plus 6 and then verify the relation between the zeros and its coefficients. So first we need to find the zeros of this quadratic polynomial. Let's call it p of x is equal to 6x square minus 13x plus 6. Now we need to split them in the form 6x square minus 9x minus 4x plus 6. From these two terms we can take 3x common outside. So 3x into 2x minus 3. From these two terms we will take minus 2 common outside. So minus 2 into 2x minus 3. This can be written as 3x minus 2 into 2x minus 3. So either this term is equal to 0 or this is equal to 0. So either 3x minus 2 is equal to 0 or 2x minus 3 is equal to 0. 3x minus 2 equal to 0 gives 3x equals 2 and x is equal to 2 by 3. And in this case 2x is equal to 3 and x is equal to 3 by 2. So we got the values of the zeros. Let's call it alpha and beta. So now we need to do the verification part. Sum of the zeros should be equal to minus coefficient of x by coefficient of x square. Alpha plus beta, or in our case alpha is 2 by 3 and plus beta is 3 by 2. By cross multiplication 4 plus 9 by 6, which is equal to 13 by 6. Now the right hand side is minus b by a. From the polynomial, coefficient of x is minus 13, which is equal to minus of minus 13 by coefficient of x square is 6, which is equal to 13 by 6. LHS is equal to RHS. Hence verified. Now we can do the second verification part, that is the product of the zeros. The product of the zeros alpha beta should be equal to constant term divided by coefficient of x square. So from this LHS is equal to alpha beta. Alpha is 2 by 3 and beta is 3 by 2, and when we multiply we will get 1. Same way the right hand side is c by a, and the constant term from the polynomial is 6. Coefficient of x square is also 6. So 6 by 6, which is equal to 1. Again left hand side is equal to right hand side, hence verified. If m and n are the zeros of the polynomial x square plus mx plus n, find the value of m minus n. So m and n are the zeros of the polynomial. So from the relation between zeros and coefficients, the sum of the zeros should be equal to coefficient of x divided by coefficient of x square. In this case it is 1. So we are getting m plus n equals m. Taking this m to the left hand side, we will get m plus n minus m is equal to 0. That will mean, sorry, this is equal to minus b by a. Yeah, alpha sum of the zeros should be equal to minus coefficient of x by coefficient of x square. So m plus n will be minus m, and when it comes to the left hand side it will be plus m. So 2m is plus n equals 0. 2m is equal to minus n, m is equal to minus n by 2. Now, from the product of the zeros, that is product of the zeros, m into n should be equal to constant term divided by coefficient of x square. So m into n should be equal to constant term is n and coefficient of x square is 1. Taking the n to the left hand side, it will become denominator. So m into n by n is equal to 1. M is equal to 1. We are already having m is equal to minus n by 2. Let's call it equation 1. Substituting the value of 1 in equation 1 gives 1 is equal to minus n by 2. It means minus n is equal to 2, n is equal to minus 2. Now we have the value for m and n. We can find m minus n, which is equal to 1 minus minus 2, which is 3. So answer to this question is 3. Find the value of alpha power 4 beta cube plus beta alpha cube beta power 4, where a and b are zeros of this polynomial f of x. So from this polynomial, we can say that the sum of the zeros alpha plus beta is equal to minus coefficient of x by coefficient of x square. So minus of minus 4 by 1. So sum of the zeros is 4. And similarly, we know product of the zeros is equal to constant by coefficient of x square, which is equal to constant term is 3 by coefficient of x square is 1. Alpha beta will be 3. We have alpha plus beta value and we have alpha beta value. We need to find the value of this term, alpha power 4 beta cube plus beta power 4 alpha cube. From both these terms, we can take alpha cube beta cube common outside. So that will be alpha cube beta cube into alpha plus beta, which can be written as alpha beta whole cube into alpha plus beta. Now we just have to substitute the values. Alpha beta is 3 and alpha plus beta is 4. So 4 cube into alpha beta is 3. So 3 cube alpha beta, we just found out it to be 3. So 3 cube into 4. 3 cube is 27 into 4. 27 times 4 will be 108. Answer to this question is 108. Now the next question is, write a polynomial whose zeros are 2 plus root 3 and 2 minus root 3. So alpha is equal to 2 plus root 3 and beta is equal to 2 minus root 3. And the general form is of x is equal to x square minus alpha plus beta into x plus alpha beta, and it can be multiplied with a constant k. K can be any value, any constant. So we need to find the values of alpha plus beta and alpha beta and substitute in this. Alpha plus beta is equal to 2 plus root 3 plus 2 minus root 3 plus root 3 minus root 3 will get cancelled. So alpha plus beta is equal to 2 plus 2, which is 4. Now let's find the value of alpha beta. 2 plus root 3 into 2 minus root 3. This is of the form a plus b into a minus b. So this will be 2 square minus root 3 square, which will be equal to 2 square will be 4 and minus root 3 square will be minus 3. So 4 minus 3 is 1. Product of the zeros is 1. So we can say that f of x is equal to k into x square minus alpha plus beta is 4 plus alpha beta is 1. This is the required polynomial. Next question is, if alpha and 1 by alpha are the zeros of the polynomial, then find the value of k. So the zeros are alpha and 1 by alpha. Now we know from the relation between zeros and coefficients that product of zeros is equal to the constant term divided by coefficient of x square. So the product of the zeros will be alpha into 1 by alpha is equal to constant term is k minus 4, coefficient of x square is 4. Alpha will get cancelled and we will get 1 is equal to k minus 4 divided by 4. Now we'll take the 4 to the left hand side, it will become the numerator. So 4 is equal to k minus 4. Now we need to take this minus 4 to the left hand side. 4, when minus 4 comes to left hand side, it will become plus. So plus 4 is equal to k, that means k is equal to 8. The answer to this question is 8. The sum and product of the zeros of 4x square minus 27x plus 3k square are equal. Find the values of k. So the values of sum and product of the zeros are equal. So if alpha and beta are zeros, then alpha plus beta is equal to alpha beta. Let's call this an equation 1. Now we know from the relation between the zeros and coefficients that alpha plus beta should be equal to minus coefficient of x by coefficient of x square. So minus coefficient of x is minus of minus 27 divided by coefficient of x square is 4. Alpha plus beta is 27 by 4. And we also know the product of the zeros is constant term c divided by coefficient of x square is 4. Sorry, coefficient of x square is a. So alpha beta should be equal to constant value is 3k square divided by coefficient of x square is 4. So we got this value as the alpha beta value. Now from equation 1 we can say this is equal to this. So equation 1 gives us alpha plus beta is 27 by 4 is equal to alpha beta, which is 3k square by 4. Now we are getting this equation. Both are having 4 as a denominator, common denominator. We can cancel them. That will give us 3k square is equal to 27, which means k square is equal to 27 by 3. K square is 27 by 3 will be 9. So k is equal to plus or minus 3. So the values of k will be plus or minus 3. If alpha and beta are zeros of quadratic polynomial kx square plus 4x plus 4, find the values of k such that alpha plus beta whole square minus 2 alpha beta is equal to 24. So we have been given this polynomial alpha plus, and we have been given this equation. From this we need to find the value of k. So we know from the relation between the zeros and coefficients, that alpha plus beta should be equal to minus coefficient of x by coefficient of x square. So in this case it will be minus 4 divided by coefficient of x square, which is k. Alpha plus beta is minus 4 by k. And we also know product of the zeros should be equal to constant term divided by coefficient of x square. Alpha beta will be constant term here is 4, coefficient of x square is k. Now it is given in the question that alpha plus beta whole square minus 2 alpha beta is equal to 24. We just found the values of alpha plus beta and alpha beta as minus 4 by k and 4 by k. We will substitute that here, so we will get minus 4 by k whole square minus 2 into 4 by k. Okay. So alpha plus beta whole square minus 2 alpha beta is equal to 24. Minus 4 square will be 16 divided by k square minus 4 2s are 8 divided by k equals 24. This will give us, by cross multiplication, 16 minus 8k divided by k square equals 24, which means 16 minus 8k is equal to 24k square. Taking all the terms to the right hand side, 24k square plus 8k minus 16 is equal to 0. Now we got another quadratic equation. If we solve this, we will find the value of k. So before solving this, all these three terms have 8 as a common factor. So dividing both LHS and RHS with 8, we will get 8 3s are 24, 8 1 is 8, and 8 2s are 16. So we need to find the solution of this equation. So 3k square plus k minus 2. If we solve it, three k square plus k minus 2 equal to 0. First let us factorize this. For that we can use the middle term splitting technique, and we can split this of the form 3k square plus 3k minus 2k minus 2 equals 0. From these two terms we can take 3k common outside, so 3k into k plus 1. From these two terms I'm taking minus 2 outside, so k plus 1 equals 0, which means 3k minus 2 into k plus 1 equals 0. So either 3k minus 2 is equal to 0 or k plus 1 is equal to 0. In this case k will be minus 1, and in this case 3k will be 2 and k will be 2 by 3. So the answer to this question is k is equal to 2 by 3 or minus 1. So next question is, if alpha beta are the zeros of the polynomial 6y square minus 7y plus 2, find a quadratic polynomial whose zeros are 1 by alpha and 1 by beta. So we have been given a polynomial, let's call it p of y equals 6y square minus 7y plus 2. First let us find the zeros of this polynomial. Let's find the alpha and beta by factorizing this using middle term splitting. So this will become 6y square minus 4y minus 3y plus 2 From these two terms we can take 2y common outside. 2y into 3y minus 2. From these two terms I'm taking minus 1 common outside, so this will become 3y minus 2. So 2y minus 1 into 3y minus 2. We have factorized it. Now we can find the zeros. So 2y minus 1 is equal to 0, or 3y minus 2 is equal to 0. In this case 3y is equal to 2, y is equal to 2 by 3. And in this case 2y is equal to 1 and y is equal to 1 by 2. So let us take alpha as 1 by 2 and beta as 2 by 3. Now we need to build a polynomial with zeros 1 by alpha and 1 by beta. So 1 by alpha is equal to, reciprocal of this will be 2, and 1 by beta, that is the reciprocal of 2 by 3, is 3 by 2. So the polynomial which we are going to build is of the form, let's call it f of x equals k into x square minus 1 by alpha plus 1 by beta into x plus 1 by alpha 1 by beta. This is the polynomial which we are going to build. For that we need 1 by alpha plus 1 by beta. 1 by alpha plus 1 by beta is equal to 2 plus 3 by 2, which is cross multiplication. We will get 4 plus 3 by 2, 7 by 2. And the product of the zeros, 1 by alpha into 1 by beta, will be 2 into 3 by 2, which is 3. So now we can build the polynomial. We got sum as 7 by 2, yes, and product as 3. And f of x will be equal to k into x square minus 7 by 2 into x plus 3. In order to get rid of the denominator, we will multiply everything with 2. So k into 2x square minus 7x plus 6. This is the answer. Next question is, if sum of the squares of the zeros of the quadratic polynomial f of x is equal to x square minus 8x plus k is 40, find the value of k. So it is given f of x as x square minus 8x plus k, and if alpha and beta are zeros, then it is also given that sum of the squares of zeros, so square of alpha plus square of beta, their addition will be equal to 40. Let's call this equation 1. So now we know from the relation between zeros and coefficients that alpha plus beta will be equal to minus coefficient of x by coefficient of x square, and in this case minus coefficient of x is minus 8, coefficient of x square is 1. The sum of the zeros will be 8, and the product of the zeros alpha beta should be equal to constant term divided by coefficient of x square. In this case the constant is k and coefficient of x square is 1, so alpha beta is k. Now the equation 1 says alpha square plus beta square is equal to 40. Now this can be written as alpha plus beta the whole square minus 2 alpha beta equals 40. Why? Because we have this algebraic identity that a plus b whole square is equal to a square plus b square plus 2ab. if we just take this 2ab to the left hand side, we will get a plus b whole square minus 2ab equals a square plus b square. So a square plus b square can be written as a plus b whole square minus 2ab. Same way, alpha square plus beta square can be written as alpha plus beta whole square minus 2 alpha beta. Now substituting the values of alpha plus beta and alpha beta. Alpha plus beta is 8. So 8 square minus 2k equals 40. That gives 64 minus 2k equals 40. Minus 2k is equal to, taking 64 to the left hand side, 40 minus 64 minus 2k is equal to 40 minus 64 will be minus 24. K is equal to minus 24 by minus 2, which will be 12. The answer to this question is 12, or k is equal to 12. Two friends went for trekking, and the trekking path which they took is of the form of a parabola that is also given in the diagram. Based on this, there are 4 questions. First question is the zeros of the polynomial in the graph. So the zeros of a polynomial, we can easily find that out by from a graph, like where the points at which the graph is intersecting with the x-axis. So in this case, it will be in this point and in this point. So the value of x at those points are minus 4 and 7. So the answer to the first question is minus 4 and 7. So for A, the correct answer is the second option, which is minus 4 comma 7. Now the second question, what will be the expression of the given polynomial p of x? So we have zeros, minus 4 and 7. Let's call them alpha equals minus 4 and beta is equal to 7. Now we need to build a polynomial, and alpha plus beta will be minus 4 plus 7. Alpha plus beta is 3. Product of the zeros will be alpha beta is equal to minus 4 into 7. Product will be minus 28. And the general form of a polynomial f of x will be x square minus alpha plus beta x plus alpha beta into a constant k. So k into x square minus 3x minus 28. Now we can also write this in the form k into minus x square plus 3x plus 28. Why? Because I just multiplied with a minus 1, and since there is a k here, it can mean k divided by minus 1 is also another constant k. So this can also be the polynomial of the given graph, and in the option only this option is there. This is not in the option. And this is in the option. So we should choose this one, and this is option number 4. So the answer to the second question is, that is B, is 4 minus x square plus 3x plus 28. Now the third question is the product of zeros of the given polynomial. So we found the zeros as minus 4 and 7, and when we found the product, we got minus 28. So the answer to the third question is minus 28. The option 1 is the correct answer. Now the fourth question, f of x is equal to x square minus 13x plus 1, then f of 4 is equal to, f of x is given as x square minus 13x plus 1. Now we need to find f of 4. F of 4 is equal to, substituting 4 here, 4 square minus 13 into 4 plus 1, which is equal to 4 square will be 16 minus 13 into 4 will be 52 plus 1. This will be equal to 17 minus 52, 16 plus 1, 17 minus 52, and we will get, after subtraction, the value is minus 35. So the answer to the fourth question will be option 2, minus 35. Now in the next question, a person throws a ball upwards and it forms a parabola path, and the path is represented with the formula like the height of the ball in each given second can be represented as minus t square plus 2t plus 8. Now we need to answer these 4 questions based on the given graph and given equation. So the first question is, find the maximum height achieved by the ball. So the height achieved by the ball is given by the equation minus t square plus 2t plus 8, where t is the time. So we can say h of t as this, and when t is equal to 0, we will get height as 0 plus 0 plus 8. So height will be 8 and it is given in meters. Now we can check for t is equal to 1. We are getting height as minus of 1 square plus 2 into 1 plus 8, which will be minus 1 plus 2 plus 8, which is equal to 9 meters. When t is equal to 2, we will get height as minus 2 square plus 2 into 2 plus 8, which is equal to minus 4 plus 4 plus 8, which will be 8 meters. And when t is equal to 3, height will be minus 3 square plus 2 into 3 plus 8, which is equal to minus 9 plus 6 plus 8, and the value of this is 8 plus 6 is 14. 14 minus 9 will be 5. So the maximum height reached by the ball will be 9 meters. It starts at 8 meter. After 1 second it reached 9 meters. After another second it again came back to 8 meters. And after another second it reached 5 meters. And if we check for t is equal to 4, we will probably get minus 4 square plus 2 into 4 plus 8, which is equal to minus 16 plus 8 plus 8, which is equal to 0. Yes, at 4th second the ball reaches the ground. Now based on this information we can answer the first question. Maximum height achieved by the ball is, when time is 1 second, the ball reached 9 meter. So 9 meter is the correct answer. First option C is the correct answer, 9 meter. Now the second question, time taken by the ball to reach the maximum height. So we just checked it. At 1 second it reached the maximum height. So answer is 1 second. Again C, 1 second. Now the third question, number of zeros of the polynomial whose graph is given is the, so the given graph has how many zeros, that we have to find out. But we can say it is having 2 zeros because it is a quadratic polynomial. From the graph we can say it has 2 zeros. One of the 0 is 4. The graph touches x-axis at 4, and the other 0 will be in the negative value of x. The graph continues in the negative x-axis also, so there will be another 0 present here, so number of zeros will be 2. For third question, number of zeros of the given polynomial is 2, option B. And for the fourth question, zeros of the polynomial are, so one of the 0 is, we know it is 4, we need to find the other 0 also. For that we need to solve the given quadratic equation. So the given equation is minus t square plus 2t plus 8. We can split the middle term, so minus t square plus 4t minus 2t plus 8. From these two terms we can take minus t common outside, so we can take just t common outside, so t into minus t plus 4, and from these two terms I will take only 2 common outside, so plus 2 into minus t plus 4. This can be written as t plus 2 into minus t plus 4. So either this term is equal to 0 or this is equal to 0. So t plus 2 is equal to 0, which means t will be minus 2. Otherwise this will be 0. So minus t plus 4 is equal to 0 means t is equal to 4. So we found the zeros as minus 2 and the other 0 we already knew from the graph, which is 4. So zeros of the polynomial are minus 2 and 4. Option B is the correct answer. We have solved 22 questions now. If you have any doubts in these questions, feel free to discuss in the comment section. Thank you.